A few ground rules to start with. All attendees to the webinar will be on mute by default. We will have a Q&A at the end of the presentation. You can type your questions on the chat window and we will respond after the completion of the presentation. Alternatively, you can do a raise of hands on the webinar platform and we will unmute you. And then you can ask your question. We are also going to record this webinar and the recording will be uploaded on the CySecK YouTube channel. So you can always refer back to the video later if necessary. This webinar is part of a series that we launched last month under the title Samgacchadhwam. May we all progress together. The objective is to cover different topics of security over the course of this series. We want to provide a conceptual overview in these webinars and then hope this will kindle your interest to explore the topics further. This is the 5th webinar in this series. The topic of today's webinar is application security beyond VAPT. Very often, application security is considered as synonymous with VAPT. The application development team focuses on building applications, and just before go live, the security team is tasked with doing a VAPT. This is a very immature state of affairs since the cost of fixing security bugs at this stage will be high, and business may not be okay with any delay to the go live. They would have made a commitment for go live of the application and will push back hard on any security concerns that can delay the go live. In a mature state of things, the security has to be baked into all stages of the application development process. Whether you follow waterfall methodology or agile methodology or any other development methodology. It's great to have Synopsys partner with us for this webinar. Synopsys is a global leader in application security products and services, and they have a significant presence in Bengaluru. The topic for next week's webinar is Cybersecurity, Emergence of Software-Defined Network. This will be in partnership with Cisco. We will open the registration for this webinar in the next few days. We have more such webinars lined up over the next few weeks, and I hope you will find this series of webinars useful. Please provide us your genuine feedback on the webinar. The feedback link will be shared at the end of the webinar. We also have an assessment arranged at the end of the webinar. The link for the assessment will be shared at the end. Those who have successfully completed the assessment will be provided a certificate. The assessment will be kept open for 60 minutes after the completion of the webinar. The questions are from the topic covered during the webinar. Certificate will be emailed to the Gmail ID you would have used to log into the assessment in the next few days. So please make sure you provide your correct details when taking the assessment, because the certificate will be generated based on the details provided by you. Let me now introduce the speakers for today's webinar. Today we have two experts from Synopsys, Sandesh Anand and Ved Prabhu. Sandesh is an information security professional with a deep affinity towards software security. He currently works as a managing consultant at Synopsys Software Integrity Group. Apart from leading the delivery of various AppSec engagements, Sandesh also helps Synopsys clients mature their abstract program. In his spare time, Sandesh enjoys running when there is no lockdown, of course, and photographing birds. Ved is an information security consultant whose areas of interest include penetration testing, source code reviews, and securing mobile applications. He currently works as a security consultant at Synopsys and loves to travel and explore places in his spare time. Now I will hand over to our experts to take you through the rest of the webinar. Sandesh and Ved, over to you.
Thank you, Karthik. Ved, can you please bring up the presentation?
Right, just a second. I will need the presenter access. I don't see the share screen option right now.
Access.
Okay.
Okay, so Sandesh?
Yes,
Okay.
I can see the screen. Can you please go to the next slide? Okay. Yeah, you can stay here. So thank you everybody for dialing in. It is really nice to be talking to so many students from Karnataka. As Karthik mentioned, my name is Sandesh Mysore Anand. I am a managing consultant in Synopsys, and today we will be talking about application security and activities beyond VAPT. Okay. So before we talk about the topic, I want to give you a quick overview of Synopsys Software Integrity Group. So we are a application security company. Sometimes we also call it software security company. And we have a combination of products which help our customers secure their software, and we also have a services organization where we perform different activities such as penetration testing, source code review, etc. for our customers, right? And we've been in the industry for a very long time, and we're always looking to hire more smart talent. Okay, can we go to the next slide, Wayne? Okay, so first of all, I wanted to start off by talking a little bit about what is the importance of application security, right? So, if you have followed security in the past, or even if you've read about hacking or cybersecurity or information security, there are a lot of different aspects to it. And most people, when we think about cybersecurity, think about networks or about phishing campaigns or about people doing fraud, etc., etc., right? But over the last about 8 to 10 years, one of the fastest growing areas of security has been application security. And one of the reasons is because now there is software everywhere. Right. So, when I started as when I graduated from VTU and I was a fresh engineer out of college, I also started out as a developer. Right. So at that time, we would only build certain websites, or certain large companies would have web applications for internal usage, or we would have what we call as thick clients, right? The things that you install, your exe files that you install on your machines. So those were what we called as applications, and that was it at that point, right? Mobile applications had slowly started, but they were not mainstream yet. Embedded software devices were also there, but they were also not mainstream. They were very few and far between. Now, cut to 2020, and today's age is very, very different. There is software in everything, right? Yes, we still have web applications, we still have mobile applications, and a lot of us use mobile applications today. But there's also software in our refrigerators. There is software in our cars. There is software in our speakers. If you used Amazon Echo or Google Home, etc. There is software in our microwave ovens as well, right? So right now, what's happened is that software has expanded from being just used to run certain applications to basically being a part of every object in the world, right? So that's one reason why software has expanded everywhere, and therefore software security or application security has also expanded, right? Because as long as there is more software, there will be more security bugs, there'll be more hackers who want to hack software. Okay, so that's one reason why application security is very important. The second reason is because of something called cloud, which you all may have heard of. Now, traditionally, we deployed applications on what we call as data centers, right? So there would be a room, air conditioned room with a lot of server racks and with a lot of cables, right? Which would host many operating systems, many computers, many databases, etc., etc. And you would run your applications through those servers, right? And these servers were also managed by you, right? So if you wanted more server capacity, you would actually buy a box of buy a server from the store, go and fix it there and connect the hardware and then deploy the application there, right? So this was the story many years ago. Today, because of the cloud, that has changed. Even if you want a new server, all you have to do is either you go into AWS, Amazon Web Services, or Microsoft Azure or Google Cloud, and you can provision a server without buying any hardware. In fact, one of the most common ways of using cloud is actually through code itself, right? So we now can write software to kind of create hardware required for your application. So even a lot of infrastructure has become software defined. Okay, so because of this, right? So from your connected cars to your connected microwaves to your connected speakers, all the way to infrastructure also being dependent on software, it has so become that the largest attack surface for hackers is now your application or the software that you write. Okay, and therefore the importance of application security has also gone up over the last many years. And this is the reason why, if any of you want to want to kind of have a career in cybersecurity or are thinking about cybersecurity as an option to study further, then a core area of interest should be application security. Okay, can we go to the next slide, Wayne? Okay. So, to reiterate the point that I made a few minutes ago, right? So, if you haven't heard of the Verizon data breach report, so Verizon is a company, which is is a telecom provider, much like either Airtel or Jio in India. They are based out of the US. But one of the things they do, in addition to kind of being a mobile provider, is that they publish a report called the data breach report every year. Okay, and what that does is that it analyzes data from many different hacks and many different security incidents and data breaches from across the world to kind of come up with certain patterns. So we all learn about how hacking and how security is changing. Okay, so this screenshot that you're seeing right now is from the data breach report from 2019. Okay, and what it says, this tells you the top 10 patterns of data breaches across the world. Okay, and number two are web applications. Okay, and if you look at the kind of the y-axis on top, this talks about the different industries, and in pretty much every industry there are web applications are close to the top. Okay, especially in public websites, in finance and healthcare and so on and so forth. So what I want to say is that these two slides and I want to reiterate the fact that web application security and application security in general is very important and something that we all have to pay attention to. Okay, wait, can you go to the next slide? Okay, so before I kind of talk more about application security, I want to give you examples of certain hacks or attacks that have happened in the last 1 or 2 years, because of weak application security. Okay, and you may have heard of some of this, you may not have heard of some of this. Some of them are very popular attacks, but let me give you a brief overview of each of them. Right, so Capital One is a bank in the US. Right, so Capital One, is one of the largest banks. They have, many Americans use Capital One Bank. And recently, what happened was they had deployed all their applications on Amazon Web Services. Okay, not all, but many of their applications on Amazon Web Services. But what happened was, they misconfigured one of their cloud servers. To allow certain things to happen, and that made the whole of their environment vulnerable. Okay, so this allowed a hacker to actually log into their systems and steal about 100 million worth of records. Okay, so 10 million is like about 1 crore. So 10 crore records were actually breached and were put on social media, and you could access it. This included names of customers, phone numbers, addresses, account information, and so on and so forth. So you can imagine this was very embarrassing for Capital One. This was very dangerous for their customers, and this could have all this happened because of a security flaw in their application. Okay, So before you think that this can only happen to either American or British companies or foreign companies, that's not true. It can happen to Indian companies as well. So here, I want to talk about two kind of companies: Checkbook.com and Creditfair. Both of them, small fintech companies from India. And if you since you're all third, fourth year engineering students, you must have heard about different kinds of databases, right? So MongoDB is what's called a NoSQL database these days, and they were both using unencrypted databases. Okay, and the unencrypted databases had sensitive information stored in them, so hackers could just go access the database and steal a lot of sensitive information. Okay, and all this because they did not follow certain software application security best practices. Okay, so this was checkbook.com and Creditfair. British Airways, the airline flight, had a airline company had a very interesting hack as well, again due to a application security fault. What happened was there is a there is a attack called MageCart. Okay, MAGECART. If you guys are interested in learning more about interesting attacks, you should definitely Google this. And Mage card is, think about, you must have heard of ATM skimmers, right? When you go to the ATM and you put your card, sometimes attackers or hackers can put something in that machine which can allow you to steal your ATM card details. Again, it's not very popular these days, but in the past it used to happen a lot. So think of Mage card as a digital skimming attack, okay? Not a physical skimming attack, but a digital skimming attack. So what would happen was, if you go into the British Airways website to say book a flight and you enter some of your personal details, this Mage card would steal that information and send it off to the attacker's server. And then the attackers would, or hackers or the bad actors, they would sell that details on the black market and kind of make a lot of money. So this again led to a lot of privacy issues for customers of British Airways. Okay, and the last one I want to talk about is probably the most famous hack in the last few years. Right, Equifax in the US is like a credit union, a credit rating company. Think of Sibyl in India is a similar example, and they have information about pretty much every American who is employed or who has ever had a job. Okay, because they have something called a social security number, which is a very important and a sensitive information of every American who works on it. So for 143 million people, they compromised sensitive information because of this breach. And why did this breach happen? Because they were using a vulnerable version of a software called Apache Struts. If any of you have done some software development in Java or J2EE, you must have heard of Apache Struts, right? And because of this, because they used the old version, many times when you get a pop-up to say, hey, update your Windows, you guys just ignore it, right? But similarly, this company kind of ignored many warnings to update one of their softwares, one of the libraries called Apache Struts, an open source library. Because of that, they had to, they suffered a major breach, and they had to pay over $700 million in fines to the local company. So the reason I'm giving you all these examples is not to scare you, but to kind of let you know that a lot of things can kind of go wrong if you don't take care of application security. Okay, and that's why it is very important for us to all think about and learn about application security. Whether you plan to go into cybersecurity or plan to go into software development, it is important for you to care about application security. Okay, Ved, can you go to the next slide? Okay, so now that we understand the importance of application security, I want to tell you what else are we going to talk about today. Okay, so first, we will do a quick recap of software development lifecycle. Some of you may have already learned about this in your software engineering classes. So we'll do a quick recap of that. And then we will also talk about what are the different kinds of security activities you can perform at different stages of a software development lifecycle. Okay, and then what we will do is we will talk about one particular vulnerability called SQL injection. Okay, some of you may have heard of it. For some of you, this may be the first time, but don't worry if you haven't heard of it. We will explain what it is. And what Ved will do, my colleague Ved will do, is he will actually show you a demo of how such a vulnerability can be exploited, and then think of it as from a security person's perspective. Okay, if you're working on a website or an application, then how do you find these kind of vulnerabilities? So we will talk about different ways of finding such vulnerabilities, and then we will wrap up with some questions that you may have. Okay. All right. Okay. So let's go back to the previous slide with. Okay, so let's quickly talk about what is a software development lifecycle. As you all may have studied, software development is a process which goes through multiple steps. Okay, so step one is planning, where someone either somebody who wants to build a software or a manager or a product manager within a company will start planning about saying, hey, we have to build a new application or we have to upgrade the application to the next version and so on and so forth. So they start planning as to what kind of features need to be built in, what are the requirements of our customers, and so on and so forth. Right. The next stage is analysis, where what they will do is basically they will shortlist the list of from the plan. They'll take all the features and everything that they wanted, and they'll shortlist and come up with a list of features that they definitely want to design and implement. Okay. Stage three is to actually design the software, come up with the different components that will be built in to make the software, right? And then kind of publish the software design for the developers and the QA people and the application owners to consume. So once the design stage is complete, it is the implementation stage, and this is where you actually write the source code, right? So developers actually write the source code in various different kinds of languages, set up databases, make sure that you're able to connect to the databases, connect to third-party libraries, and so on and so forth. So this is a very crucial stage of the SDLC. Once the application development is complete, there's the next stage is called testing and integration, where you want to, before you release it to the customer, you want to make sure that it's actually working as expected. Okay, so that's where a lot of testing happens. And the last stage, this should be number 6, by the way, not number 5, is what's called maintenance or deployment and maintenance. So what happens here is that you make the application available for your end customer and they start using the application. Okay, and the reason this is a cycle and not a straight line is because the nature of software is that you never stop developing software. Even once a software is being used by a customer, you keep on improving it, you keep on having different iterations. Okay, and that's why you see that software development life cycle is usually cyclical. Okay, so this is SDLC. Now you may ask, is there only one type of SDLC or are there many different kinds, right? So as you can see on the right here, there are many different kinds of SDLCs. The most popular and the most old school one is something called as the waterfall model, where every step happens step by step, and usually to go from stage 1 to stage 6, it may take 3 months, 6 months, or sometimes even longer. Okay, now there are many other models which I'm sure you can learn from your textbooks or from Google, but I will talk about the last one here, which is called agile development. Okay, so this is kind of a very popular model these days, and a lot of companies and software developers are using agile. So what agile does is, instead of planning all the features and everything in one shot and then going to the analysis stage, they will only plan, analyze, design, implement, and test the most important feature in an application and release that to the customer. Okay, and only once they learn that the core feature is implemented properly will they implement the other features and deploy that as well. So what that means is that teams go through this cycle very fast, right? Sometimes it can happen in 6 weeks, some companies do it in 3 weeks, some companies do it in 1 week, and many companies such as like Netflix and Facebook and Flipkart, etc., do it multiple times a day. So they go through the whole process multiple times a day sometimes, right? So what this allows is that it allows for rapid development. It allows for new features to be available for customers very quickly. Okay, so what I'm going to talk about in the next slide is what are the different security activities that you can do in each stage of the SDLC, irrespective of which type of SDLC you have. Okay, any type of SDLC, similar security activities are in question. Okay, Ved, can you go to the next slide? Okay, just hit, yeah, thank you. Okay, so the reality is that, as Karthik very poignantly mentioned at the beginning of the presentation, that security is not something you can test at the end of the software development lifecycle. Many people assume that once the application is developed and it's deployed, you can do a quick pen test and you can fix all the issues that you find. Right? Penetration testing is a very good way of finding security vulnerabilities, but it's definitely not the only way. Okay, and one of the issues with penetration testing is that you spend all your time doing requirements design, test code, QA, and then find vulnerabilities. And then if you realize that there was a mistake in your requirements phase, then you have to go back all the way to the requirements phase and start fixing everything again. Okay, instead, what instead the right way of doing application security testing or application security analysis is by having different kinds of application security analysis happen in different stages of the SDLC. Okay, so in the requirements and the use cases stage, you can do something called abuse cases and develop something called security requirements. Okay, so I will not go into too much details on these because it will take way more than 1 hour. But abuse cases, think of them as the mirror image of use cases. So if you guys have learned a use case, for example, a use case may say, hey, you need a username and a password to log in to an application. Okay, an abuse case would be, is it possible to log into the application without a password? Okay, so it's just a abuse case. So when you develop your abuse cases like this, in the future, when you do risk analysis or when you do analysis stage, you can make sure that you build the application in a manner where the abuse case does not become real, right? That no matter what, a user cannot log in without a password. Okay, so once you come to the design stage, you can do something called risk analysis or design risk analysis. Ved will talk a little bit more about that later. When you're writing source code, you can do something called code review, and there are two different flavors of code review you can do. One is actually running scans or doing analysis on the source code that you've written, or you can also do something called software composition analysis on some of the open source components that you may be using. And Ved will talk a little bit more about both of them as well. Okay. Finally, we also spoke about penetration testing and security operations, right? Penetration testing we already spoke about, and what security operations does is once an application is deployed into production, you should monitor the data coming in. You should monitor the traffic that's coming into the application to analyze if there have been any attempts to hack an application or to perform a breach, right? In that case, what will happen is that if you find that some attacker is right through operations, then you can alert your systems, block that user, or take other preventive measures, right? So that's what happens in security operations, and this is a continuous cycle. Okay. So to wrap up, these are the different. So to kind of summarize, as I mentioned, application security is not just about testing at the end of the life cycle, but about doing multiple different kinds of activities at different stages of the software development life cycle. Can you go to the next slide, Ved? Okay, so I'm going to hand it over to Ved, who will talk to you a lot more about one particular type of vulnerability and show you how you can find these vulnerabilities in various different kinds of security testing. Ved, over to you.
Okay, thank you, Sandesh. So hi everyone. So far we've spoken about why security is important and that it should be incorporated in your daily routine as part of your SDLC. So now I'm going to be talking about one specific vulnerability which we call the SQL injection. And as you know, SQL, for people who know, for people who don't know, it's basically a code injection technique, and it's basically one of the top categorization under the OWASP Top 10 Guide. For people who are not familiar with the OWASP Top 10 Guide, it's basically a document that is used by developers as part of their best coding practices policies. So usually developers can look at this guide and they can look at all the vulnerabilities that you can find in applications these days. And the guide basically contains the names of the vulnerability, basically the categorization. It tells you how it looks in code. So it gives you an example of how bad code looks like. It gives you a recommendation of what libraries or what kind of coding methodologies you can add in your code to actually fix the issue. And it also gives you different kinds of recommendations with respect to languages used by the developer. So in short, as the name suggests, SQL injection is basically a technique where SQL queries are appended directly into the database using user manipulatable input fields. So malicious code can be injected into the database in the form of SQL statements. So the next slide is going to be a brief demo of how an SQL injection can lead to a compromise of an application wherein a user can actually log in to any other user account without a password. So the demo I'm going to show you here is on a vulnerable application which is called the demo.testfire.net. It's available on the internet, and it is a purposely vulnerable application for users to actually go ahead and test and run scanners and like find vulnerabilities on their own. Okay, so this is how the login page of the application looks like. So we are actually navigating to this particular URL that is mentioned earlier. So again, just to reiterate, this is purposely vulnerable application which can be accessible on the internet. So if you look at blogs and like of this particular application, you'll be able to like understand what are the different vulnerabilities that are there in this application, and you can also kind of follow the steps to reproduce to actually see if you can reproduce the same vulnerabilities, because the vulnerabilities that you find in this particular application are more or less the vulnerabilities that we as pen testers find in other applications. So let's take the login page here, for example. So the login username of the admin user is admin, and the password is also admin. So this is actually found on like on the internet, where you can actually look at the usernames and passwords. So now what I do is, now that I know that the username of the admin is admin and the password is also admin, I'm going to try to bypass the authentication just by doing the username. So now let's take an example of an invalid login. So now if I enter the username as admin and if I put like an invalid password, the application is going to give me an error saying that sorry, boss, you're not allowed to log in because your username or your password is invalid. So now that I know the username, what I'm going to do is I'm going to enter a particular payload, which is going to directly interact with the database, thereby allowing me to actually log into the application without a valid password. So let's take this password, for example. I'm going to do AAA, and so this is a payload that I'm going to enter. After the invalid password, I'll be talking more about what this payload is and how it actually interacts with the database. So let's try this particular payload out. So I'm entering a valid username and an invalid password. And as you can see, I've actually successfully logged into the application. So let me just show you the payload again. So I entered an invalid password. The password is actually supposed to be admin, but what I've done is I've entered an SQL payload here, and I'll be explaining more about how it happened in the backend and what actually triggered the login without a proper password. So what do you think actually happened here? So let's take an example of the SQL query that is actually interacting from the application to the database. So take, for example, this being the query that is interacting with the database. Here there is a select statement where the username is is the $uname and the password is a $password. So this is basically the user input which is being taken inside the application. So what I've done here is I've entered the username, which is admin, and the password with the payload, as you can see here. So when it goes inside the query and it actually processes this particular input, what is going to happen is it's going to take the username as admin and password equal to the invalid password that we've got. And since I've entered an OR condition, so it also adds that as part of your query, which actually treats it as a single query altogether. So when this gets processed, what happens is username equal to admin. So username equal to admin is true, right? So it's going to take true. Password equal to AAA is obviously false. So it's going to take it as false. And since 1 is always equal to 1, that is also going to be true. So as you know, and always takes first precedence. So when you take true and false, which means if you're doing a 0 and 1, it's going to be a 0, which is false. And when you do a 0 and or 1, so or obviously if any one of the condition is satisfied, you're able to, it's going to give you a 1 anyway. So this is actually what's happened. So if you know how, what kind of database is used or how the query is being used or how the user input is added as part of the query, you would be able to manipulate the database in any way possible. So one example which I have showed you right now is where I'm entering an invalid password and I'm actually logging into the application itself. So another way that you can do is something like this, where you actually do an admin and you put a single quote and you comment out the rest of the query. So next, what you do is just put any random value. So all I've done here is I've put a single quote and I've commented out the rest of the query, and you'll be able to see that I'm still able to log in. So in this aspect, what I've done is I've entered admin, and what I've done is I've commented out the rest of the code. So it's not even checking for a password. So as long as the username is right, I will be able to log into that particular username. So again, so you can be creative and you can like try different methods of SQL injection in this particular login page. Again, so the deal is there are many vulnerabilities in this particular application, and what I've shown you right now is just SQL injection. So you can always look at blogs for this particular application, and you can reproduce these issues, because these issues will be found standard in the application. So you can always go ahead and try. So this is how an SQL injection happened. So if you guys have any questions, please feel free to type out the question in the chat window. Okay, so now that there are vulnerabilities in applications, how do you find them? And how do you, in the end, fix them? So there are 4 methods that we can talk about today, which is number 1, penetration testing. So since today's topic is application security beyond penetration testing, I'm not going to be talking too much about penetration testing. But one case is where you do a pen test, wherein you have the access of the application itself, and you do different kinds of testing, which involves checking of encryption, you check for authentication, authorization, input validation, you check for injection attacks, you look at session management, information leakage, and even server configurations. So these are some of the classifications of vulnerabilities that you can usually find in a pen test. But we're not going to be covering much more of penetration testing, and I'm going to be focusing more on the other 3 points here. The first one, which is source code reviews. Next is software composition analysis, and the other is design reviews. So let's talk about source code reviews. So source code reviews, again, by the name, it itself is pretty self-explanatory. So it's the review of source code. So basically, developers usually give their entire source code, or they give their binaries to us, and what we do is we do a complete thorough manual come automated check of the entire source code, and we look for vulnerabilities that can be present, which might lead to an exploit, which can compromise their entire infrastructure or the company itself. So Sandesh, in his earlier slides, mentioned about different hacks that have happened in the recent past. And all of that, or most of that, can be found in one of the detection methodologies, such as secure code review, or what we call a source code review. So the objective of doing a source code review is, one, to find vulnerabilities in the source code, because it is much more easier to find vulnerabilities in a source code than in a pen test, because you have access to the entire source code. It's a white box assessment, so you have the entire source code in your hands, in your laptop. So now you would have to look at how the application works, like how the flow in the application works. You'll have to look at how login mechanism works. You'll have to look at how authentication works, all in the form of code. So it's actually a little more easier to find vulnerabilities in a source code than a web application pen test. Following, after we find vulnerabilities in a source code, what we do is we always recommend or provide remediation to actually fix these vulnerabilities, so that developers are familiar with what implementation has to be done to fix, or like as a solution for this vulnerability. So let's take an example of the vulnerable code that we discussed earlier. Let's say, for example, there is a login module wherein there is a username and password which interacts directly with the database. So say, for example, this is the query that is being executed as part of your SQL query. So what goes in here is that you can see that there is a username field and a password field, and the values of those fields are directly appended as part of the SQL query itself, and there is no kind of security check in place. So I'll talk about security checks in like the next slide. But ideally, what is supposed to be done is that there is some kind of validation on the input that is being sent inside the query itself. Like if you look at the demo that I showed earlier, I'd put a special character in the username or a single quote, or like I'd put different payloads to actually which have special characters in them. And what has happened is they've directly been appended into the query, like you see here, and it's treated it as one single query. So what has to be done is that ideally these have to be sanitized before they're actually sent into the query. So this is like an example of a vulnerable code of how an SQL injection can arise in an application. So if you look at this particular code snippet, it's creating a connection string to the database server. It's going to so this is the query that's going to be sent to the server for checking. So it's going to send the username and password, and then it's going to get executed. And based on the results, it's going to proceed further. So if the result is 1, it's going to say that the username and password is valid. If it's 0, it will probably say that your account is not created or you've entered an invalid password, or there is no such user in existence. So, so since we're talking specific to SQL injection, there are 4 basic kinds of remediation processes that we recommend. The first is the use of prepared statements. The next is stored procedures. The third one is to whitelist the user input. And the fourth is escaping. So I'll be talking a little more about escaping after I talk about 1, 2, and 3. So prepared statements and stored procedures are basically the most recommended forms of remediation that we would provide, because what happens is when you are using any of these implementations, right? When you're using a prepared statement or a stored procedure, what happens is the entire value that you're entering in the input field is treated as a value itself, which means it's not going to append itself as part of the query. So it's only when you append a value as part of the query and it executes as one single query is when an injection attack can actually arise. But here what happens is, if you look at the code snippet provided below, it's treating this as a separate variable, and the variable assigned to it is going to take a parameter value which is separately taken or captured from the SQL query. So what's going to happen is it's going to take the username at username, and the at username is going to be taken from the text field, which is going to be initialized as a param array value, and it's going to treat that as one single value. So this is actually one way in which you can actually remediate SQL injection. So for those who are actually not aware of how prepared statements and store procedures work, there are actually a lot of blogs that actually help you to understand how these implementations work. Because the ideal recommendation for SQL injection is to use prepared statements and stored procedures. The other thing is the use of whitelisting. So there are cases where there's an input field, and the input that is required to be entered in the input field is only alphabets. Like say you're entering your name. So there is no ideal scenario where you have to enter special characters in your username. So in that case, you basically whitelist your username to only have alphabets. So when you whitelist certain characters or numbers, right? So what happens is anything other than that whitelisted set list, right, is not going to be accepted in the application. So if there is a whitelisting mechanism of alphabets, if I enter a number, your application is not going to it's not going to process that input because it's whitelisted only characters to be allowed into the application. So if I'm entering a number or a special character, it's going to throw me out. It's going to give me an error. It's going to do some kind of exception handling to that. So that is another way of remediation for SQL injection. The other thing, which is again a common practice against SQL injection, is to escape user input. So escaping is basically you can remove or add new characters. So if there's a single quote So you can write a backend code which says that if the user input contains one single quote, append one more single quote to it. So if there are two single quotes, the query will actually not even run, because the syntax needs to be perfectly right for an SQL injection to occur. So there are like a lot of dependencies involved for you to successfully perform an SQL injection attack, because number one, you need to understand what kind of database is used. Number two, you need to know how the syntax works. So if you're using a different syntax of a different database in another in the database that is used by the application, it's not even going to successfully parse the query, because the syntax is completely wrong. So in many cases, what we've seen as pen testers is that developers usually append or they remove certain characters. Like what happens is, if we put a single quote, they either add a new single quote, or they put a slash, or they put a backslash, or in certain cases, if they see a single quote, they just remove it completely. But based on the testing that we've done over a period of several years, what we've seen is that there are several cases where these implementations can be bypassed. You can change the encoding mechanism. You can you can add another special character. For example, there are like several like mechanisms in which you can actually bypass this. There are many workarounds and alternatives to performing one SQL injection. So this is basically how you remediate like an SQL injection in a code level. Okay, so now we're talking about software composition analysis. So this is one more mechanism in how you can detect vulnerabilities at any stage of the development cycle. So so basically, a software composition analysis, as you see the slide here, it's an automated solution to find vulnerabilities in an open source third-party library. So let me tell you what a library is in short. So a library is basically a collection of precompiled code that can be used to perform certain operations. So ideally what happens is developers need not write one bit of code over and over again. What they can do is they can just import a library which already does the job for them, and that's it. So that's all they have to do, is where they just have to import another on the internet, and they're sorted. All they have to worry about is taking care of the other aspects of the entire development or their entire code base. So what we've observed is that like companies these days, they use a lot of open source libraries, and they necessarily do not know what vulnerabilities are present in them. Because if I have like published a library on the internet, and say, for example, there are vulnerabilities in them, and you import those libraries for your purposes, the vulnerabilities are still going to exist in your application, because the code base of my library has a vulnerability. So a software composition analysis basically takes care of all of that. You basically run a small scan, and then it will give you a list of all the vulnerabilities that are present in your third-party libraries. So I'll also be giving you a brief demo of how a software composition analysis tool works. And all you have to do is just upgrade to the latest version. Like, say, for example, if you're using a jar file which is version 3.1, all you'd have to do is upgrade to the latest version, which is maybe 4.0. Okay, so I'll just give you a brief demo of how a software composition analysis tool works. So in this case, I'm going to show you a demo on a dependency checker. There is an installer link, which is again open source. You can just install this. There are different ways in which you can use this tool. So just a second. Okay, so this is basically the tool that I've downloaded from this particular link. So for people who are watching, and if they want to do like a hands-on, all they have to do is go to this particular link, and they would have to just download the tool itself. So you go into the bin folder, and there you can see that there are executables for both the Windows and Linux operating systems. So since I'm using Windows, what I'm going to do is I am going to run the software composition analysis tool on this particular library. So I have an application source code and I am using this particular library to perform operations within my source code. So now I have to check if there are vulnerabilities in this or not. So what do I do? So number one, I can install a dependency checker. I go into the bin folder. I open command prompt from here, and I have to enter this particular command. I'll even explain what this means. So we're actually initializing the executable. We give the project a name. We give the path to the jar file that has to be scanned. And then we also give the out file as to where the output of this scan must lie in. So this is how the tool works. All you have to do is initialize this from the command, and it's going to give you an output. So it says that the analysis is complete. For people who are downloading this tool and running this for the first time, it's going to take a long time because what this tool does is it actually extracts the CVE IDs. So there's a repository of all the vulnerabilities that are present in third-party code. You can check online. You can check. They have CVE versions. So what it does is it copies a local. It extracts a local copy of the CVEs that are found till date, and it maps it to the library that is being scanned. So let's go to the output of the file. So this is how the output of the file looks like. So it actually tells the user that it's scanned a particular file, and it says that there are 3 vulnerabilities found, and it's run the scan on one particular dependency. So it also gives you the vulnerability that is present in that particular jar file. So it tells you that on these particular links to actually find more details with respect to that particular vulnerability. And so basically, this gives you a HTML output of how of what vulnerabilities are present in that particular library. So this is how a software composition analysis tool works. There are many open source. There are commercial tools as well. Again, it depends on how and what you want to implement to your code base to actually make it more secure. So the third part of detecting vulnerabilities is design reviews. So this is a very important aspect of security. So what a design review does is where we actually look at the entire design of the application. So it's just not the source code. It's just not the web application that of the entire application that we look at. We look at the entire A to Z of the application. So we look at some of the criterion for a design review is first to evaluate against the requirements. So during the requirement stage, people get together and they talk about things that they want as upgrades in the application. Next thing is where we actually evaluate against security implementations. Like for example, if there's been a requirement for a particular feature, like an OTP functionality, we even evaluate against security implementations that have been made for that particular functionality. And how do we do that? We take interviews, we do a review of the architecture diagrams, and we also look at implementations that have been made in a code level with respect to that particular security implementation. So talking about interviews, so when we get a design review, we actually take interviews with the application teams, developers, CISOs to understand what the requirement is and what kind of security implementations have been kept in place. So that's something that we do initially. We go into the client place and then we call, we schedule interviews with all of these people. We get an understanding of what has been made to the design and what change has been made to the design of the application. And then we look at architecture diagrams of that particular application. We do an entire review of the architecture diagram to see if there are any loopholes or if there are any threats that that are there in the application which can lead to a vulnerability or an attack. And then what we do is we actually confirm steps 1 and 2 by actually looking at code level changes that have been made in the application source code. And following that, what we do is we always recommend like certain implementations to be done to the design. If we find something wrong, like if we see a security loophole, what we do is we actually go ahead and provide recommendations of what they should do and how they should proceed to actually make their application better. Okay, so let's take an example here. We're talking about a login page of a web application. So at the top of my mind, some design questions that I would probably ask is, so let's take an example of a login page. So the user is logging into an application. So let's keep this as the scope for a design review. So some of the things that would come into my mind is to check if I can like a brute force a password by knowing a particular username. I can check if I can check how the username and password is interacting with the database, and if it is like improperly done, it can lead to injection attacks. I can check how authorization is done. Is it part of is authorization done as a cookie? Is it done as a JWT token, or is it single sign-on? So based on all of this, I can think of different features that are there in a particular login page. So these are some of the things that you can possibly look at when you're looking at a login page. And what you do is you actually go and look at code level implementations as well. If like proper like there is restriction on how many attempts, how many failed attempts is possible. You look at if secure attributes are applied to a particular cookie, or you can see that JWT tokens are properly incorporated in the application. So this is something that we look in design reviews on the whole. So I think that was all I had.
Okay. So Karthik, should we take questions now, or how should we go about this? Okay.
Yeah, sorry. So I think there are a few questions on the Q&A chat window.
Yeah.
If you can answer those first, and then if you still have time, then we can see if people can do a raise of hands and ask questions as well.
Okay. Good. So let me do this then. Ved, I'll read out the question, and then if you want to answer, you can answer. Otherwise, I can take it. Okay.
Sure.
Okay, so the first question is in which phase? Okay, there were the first couple of questions were not very clear. What is the expansion of FTC? Well, FTC stands for Federal Trade Commission, but I don't understand the context there. So let me go on to the next one. In which phase of the SDLC security model can be incorporated? So let me take that. So as I mentioned, in every phase of the SDLC, you can incorporate security testing, but the most important are the ones that Ved spoke about today: code review, security code review, composition analysis, penetration testing, and design review. Those are the 4 different things you can do, and they all happen in different stages of the SDLC. Kindly explain the agile model again. I would recommend you to kind of, there are a lot of really good resources on agile methodology that you can go on the internet and find out. But to keep it very short, agile model basically, the idea is to improve the pace of development. So instead of releasing your software once every 6 months or 9 months, you can kind of release your software much faster, and also you build the most important features first, and then build all the other bells and whistles, right? So that's the kind of the funda behind agile. Agile SDLC, but there are a lot of really good resources on the internet. I encourage you to go learn again. Okay, so Ved, this question is for you. SQL injection could be solved by using CAPTCHA. Is my understanding right or wrong?
Okay, so the deal here is just by implementing CAPTCHA in every input field or form does not actually serve the purpose, because they are 2 different things. Keeping a CAPTCHA will actually act as a rate limiter to the number of attempts that you do to a particular form. But SQL injection, on the other hand, is where even one input, you don't need multiple inputs. You just need one particular form submission to actually work, which is actually interacting with the database. And basically, they're 2 different things, right? That's my That's going to be my answer.
Yeah.
So in short, no, it's not going to help. You will still need to secure your database rather than putting a rate limiter.
Yeah. So that's correct. I mean, capture can help you solve certain other kinds of security issue, like if you want to protect against brute forcing, or even if you want to protect against something like CSRF. Sometimes, although capture is not a very good defense against CSRF, but for SQL injection perspective, captures are not very helpful. Okay, the next two questions seem to have some typos, so I'll just skip that. Oh, let's go to this one. This one's a little more interesting. So wait, this is for you again. How can we log in within the password? I mean, in the database uh, with predefined username and password. Only if they match, we can log in, right? So he's asking you to explain how you could log in without the username and password matching with what's in the database.
Okay, so let me take you back to a slide that I explained. But so let's look at this slide, for example. So here, this is basically a query where there is a check on what the username and password is. So what I've done here is you're absolutely right. There's going to be a match on what the password is going to be. And based on that match, it's either going to give you a true login or it's going to give you a false login. So if there is SQL injection in this particular query, what's going to happen here, if you look at the query number 2, I have entered a wrong value. So if you look at this entire query as a whole, this is what is going to go into your database query for validation. So it's going to check for the username. It's going to say that the username exists. And once the password is false, it doesn't matter. It does not matter if the password is false, because there is one more condition here where I've added 1 equal to 1. So as you know, 1 is always equal to 1. It's always going to give you a true. So even though the password does not match in the database, it's definitely going to give you false. Like after validation, the database is going to give you a response saying that the password is wrong. So it's going to give you false. But when you look at the query as a whole, what's going to happen is in the end, it's going to still give you a true, because true and false is going to give you 0, and 0 or 1 is going to give you 1, which is true. Does that answer your question?
They can't unmute, but I think that was a good explanation. Thank you. Okay. So one more question, which was similar to what you just spoke about. So let me skip that. So the next question, I can take this, I guess. Which SQL injection is more common, in band or inferential or out of band? So I mean, in band is the most common one, because you usually have some kind of an error message to go by, so it makes life a lot easier. Out of band and inferential are pretty hard. When I say hard, I don't mean that a skilled hacker cannot do it, but maybe someone who's learning SQL injection newly, it's harder to identify that bug in the pen test. But when you're doing a code review, it doesn't matter if the SQL injection is in band or out of band or whatever it is. You can very easily find it, right? So this is one of the reasons why we use different kinds of security testing to find vulnerabilities. In band versus out of band is much harder to discover in pen testing, but in source code review, there's not much difference in difficulty. It's a good question. Is it possible when username and password both are wrong and still possible to log in? I'm guessing this is in the context of SQL injection. The answer is yes, even if the username and the password are wrong. But if the username field is vulnerable to SQL injection, we can definitely exploit it as well. It's not always possible. It's only possible in certain scenarios. Okay, next question. How to believe third-party libraries may contain vulnerabilities? So that's a good question. I think Ved kind of already answered your question. You can use tools like OWASP dependency checker, which he demonstrated, which are free to use, which you can download and run a scan to find out what kind of vulnerabilities they have, and if they do have vulnerabilities, then you can take remediation actions. Okay. Next question. Why can't the dark website be tracked and blocked? Okay, this is a really good question. Unfortunately, answering this question will probably take many hours, but let me try to explain it to you briefly. Right. So the way the internet functions is that it makes it very hard to block a single website from everyone. While either the government or somebody can block certain websites, hackers and bad actors can find workarounds to go ahead and access that website. Okay, it's because of the nature of the way the internet functions. You can use many different things. I don't want to talk about what those things are, but in general, there are many different ways of bypassing this blocking. So instead of just blocking access to certain things, we recommend that we use something called defense in depth, where just blocking is not sufficient, but you need to do other things as well to make sure your software itself is secure, in addition to many other security operations things. But to answer your question again, these websites are actually blocked. So even if you know some of these websites, you will not be able to go access it. But a skilled hacker or a bad actor will still be able to do it because of the way the way the internet functions, right? So that's why blocking is only one step and not sufficient to solve issues of data breach and data being stolen. Okay. Next question. Wait, let me know if you want to take this. Otherwise, I can take this as well. Which is the most secure method of authentication?
Yeah, I can answer that. You can add
Sure.
on.
Go ahead. Yeah,
So
go ahead.
from my understanding, there are different kinds of authentication mechanisms. There are form-based. So form-based is something that we saw as an example here, where you enter a username and password. So basically, there are many things that need to be right for you to actually implement a secure login, like a form-based login. The other thing is that you can use a token-based login, or there are even biometrics that you can use to actually log into an application. There are several ways in which you can actually try and authenticate into a particular application. So I would say that I would say biometric or even proper implementation of form-based or token-based is going to be a good idea. You can
Okay.
add on to that.
Yeah, so Ved is correct, but let me add some more information, right? So what do we mean by authentication? Let's take a step back. So authentication means that if I am saying that my name is Sandesh, how does an application actually know that I am Sandesh? Right? That is what authentication solves. So one way of solving it, as Ved mentioned, is using a password, right? So only Sandesh knows Sandesh's password. So if I've entered the right password, then the system knows that I'm Sandesh. So that's one way of authenticating. There's another way of authenticating which is called biometrics, right? So which is your fingerprint or your iris scan, etc. So I don't know my fingerprint, but I have a fingerprint. Okay, so that's another way of authentication, and there are several other ways as well. But if you have to categorize them into three categories, they can be this way. Okay, something you know, something you are, and those are the three different categories of how you can do authentication. So what's an example of something you know? Password is a good example. Only I know my password, right? In theory, you should not be sharing your password, so nobody else knows your password. So that's one form of authentication. Second form is something that you have. So something that only I have but nobody else has, and therefore I can authenticate. An example is a mobile phone. Okay, so therefore you can send me a two-factor authentication token like an SMS or OTP through SMS or OTP through other applications to do a second-factor authentication. Okay, that's what you have. The third one is what you are or who you are. Okay, that is some characteristics of your body which is unique to you. Okay, a good example is biometrics. Okay, so there are three different ways. So your fingerprint is probably something that you are, or something that that who you are, right? So there are three different ways of authenticating a human. Now, the best way to authenticate is to use a combination of at least two of them. Okay, and that's what's called multi-factor authentication. So instead of just using passwords or just using OTP or just using biometrics, you should use two of them. So in that way, for example, if somebody has stolen your password, they still cannot access your account because they also have to get your OTP, or they also have to have your biometrics. So it makes it much harder for hackers to then steal your authentication credentials. Okay, so there are three different ways to log in, authenticate. The best way to do it is to have at least a combination of two of the three, and that makes it much harder for an attack. Okay, I hope that answered your question. What is the difference between prepared statement and stored procedure? I would highly encourage that you Google this. It's a very easy thing to learn. They're basically different ways of accessing or interacting with the database programmatically. But this is something you can very easily Google. So I would recommend that you go ahead and do that. I just want to make sure that I answer all the security questions. So next one. The web applications are changing its features, adding or deleting, and many more. In these kind of scenario, how frequently we need to do VAPT test for such an application? Okay, very good question. Wait, do you want to take that?
Hey, I'm sorry, I didn't get the question.
Okay. Okay, so let me take it and then you can add on. Okay, let me repeat the question. The question is web applications are changing its features very frequently. In such scenarios, how often do we need to do a VAPT test? Okay, so the answer to that question is it depends. It is very hard to say. For many companies, and depending on the kind of change, you may have to do a VAPT every time you deploy the application to production. Okay, but then again, what kind of change you do is also very important. So for example, if you make change to just the UI, okay, if you change the color of the banner from orange to yellow, well, maybe you don't really need another VAPT because the change you made was very small. On the other hand, if you made a change to the authentication scheme, for example, if you moved from a single factor authentication to a multi-factor authentication, then you definitely need a VAPT, right? So it is very important that you understand the context of what has changed and then decide whether you want to do VAPT or not. Okay, and this is not just about VAPT, as we mentioned, every security activity, right? Whether it is software security code review, software composition analysis, design review, pen testing, all of them depends on what changes happen. This kind of an approach is called a risk-based approach. Okay, you evaluate the risk of the changes that you have made, and based on the risk, you come to a decision on what activities need to be performed. Okay, anything you want to add, Ved?
No, Sandesh, I think that was perfect.
Okay, next is a very hard question, so I'll give it to Ved. How do you trust applications on the Play Store, whether they are secure or not?
Okay, so this is an interesting question. You cannot be entirely sure. You have to be like there are different things that you can look out yourself when you're actually installing or downloading a new application or an app from your Play Store. So when you install an app, right, there are like permissions that it requires, like for the application to run. So there's some things like small things like this that can actually protect you against bigger things later. Wherein, like if you're using like a news reading app, if you're downloading a news reading app, it necessarily does not require you to access your camera. So if you look at certain features or certain permissions that it requires, which you feel is not required, those are some things which you can turn off. But by default, they usually take it all in, and unless you accept all, they will not let you install the tool. You need to further go into your app settings and then like disable it later. So these are some small things that you can do from your end. But again, like it's a very tricky question. It's like it's actually really hard to find if you're having like a good application which does not have a vulnerability or a virus or a backdoor.
Yeah.
Sandesh, anything you want to add on?
Yeah, so I think you covered most of the points. So I would say there are two different aspects that you have to be concerned about. One is the security, posture of that application. So do they have? Is it a good? Is the intention good? Does it have any malware in it, etc., etc. Right. So that is really hard to identify as a end user. There are many tools on the internet which you can use to find out what other users have said if it's a malware or not, right? So doing some due diligence, doing some research can definitely help. The second thing, which is what Ved focused on, is about privacy and about data sharing. Okay, so every application requires you to have some permissions, and today Android and iOS allow you to they will make it very easy for you to understand what kind of permissions these apps are requesting. So you have to use your awareness, use your common sense to ask the question saying, hey, does this application really need to know my location? If not, then why should I give it? Okay, so either you can deny permission to use some of that features, or if you think that it's just asking for too much information and it's a danger to your privacy, then you should not use the app at all, right? So it's important to do your due diligence, important to do your research, and then before you download an application. Okay, what else? So next question, either JSON web tokens or session cookies. I mean, it really depends. I mean, this again really depends on what you're using, what is the architecture and design of your applications. From a security perspective, both JSON web tokens and session cookies can be used securely. So from a security perspective, it's more important that irrespective of what you use in a secure manner. Like that's what's important from a security perspective. I'm not entirely sure what this question is, so I'll read it out. Whoever typed it, if you could clarify, it will be helpful. How are modified application code are created without the actual source code? Yeah, I'm not sure what this means. So whoever asked this question, if you can retype the question, I'll be happy to answer it. Next question is, should we create a SQL query? If yes, how? Or use a cheat sheet? So if you're talking about like a SQL injection payload, then there are plenty of cheat sheets available. on the internet. But if you want to practice these things, then you need to start with the basics. There are many different ways of how getting started with some of these attacks, and there are plenty of resources available on the internet that you should use. But I will say this: that no matter what you do, it is very, very important to make sure that you do not try any of these techniques on applications that you're not supposed to. Okay, only try it in your local environment, only try it on sample applications and not on production applications. That is very, very important, and that is something all of you have to keep in mind. Okay, all right, next question. How to protect our data on the internet? Whenever we search information on the internet, we may get into non-secure pages and where our data may be hacked. How to know whether a web page is safe or not? Good question. I would say it is similar to the question about the app on the Play Store, right? There are certain things you can do to make your activity on the internet more secure. On the other hand, it's difficult to be 100% sure all the time. Even experts sometimes make mistakes. Okay, so there are a few things. I mean, again, this is probably a whole 1 hour webinar on its own on how to stay secure on the internet. But some of the things I can think about off the top of my head are, use password managers, generate really long passwords. And when you're using websites, there are a couple of extensions you can install on your browser, on Firefox and Chrome, which will help you with all these privacy things, right? There's something called HTTPS Anywhere, which will make sure that even if you're accessing an insecure website, you can kind of initiate like an SSL connection to make it run. So that is helpful. There are other add-ons like Privacy Badger, which will turn off some trackers, who track your data. Like, many companies just track your data wherever you go. This will turn off those trackers, etc. You can also use ad blockers, which sometimes track your data. So there are many different ways of doing it. The important thing is there is no one silver bullet. There's no one solution. You have to kind of be careful. You have to be vigilant, and you have to take measures to keep yourself secure. Okay, next question. What is the use of integrity? Okay, that's a pretty generic question, but let me answer this in the context of the topic we are talking about. So if any of you have taken computer security class, or if you take computer security class in the next semester, you will hear of something called CIA. Okay, it's the triad of security. So CIA stands for confidentiality, integrity, and availability. Okay, confidentiality means that the data that you are sending from client to server or one user to another user should be confidential. That means the information that I don't have access to, I should not accidentally get access to it. Okay, so for example, Ved's bank statement, I should not have access to. So that's called confidentiality. I'm making it very simple, but just to explain, there's a lot more detail to it. But at the core level, that's what confidentiality means. Availability means that the data, or the websites or the applications you use should always be available. Okay, so if the application goes down, then, for example, if a bank application goes down, then I can't use it. Right? So availability is a very important cornerstone of security. The third important cornerstone is what's called integrity. Integrity means that the data I sent should not be modified by somebody else without my permission. Okay, so if I go to some e-commerce site and I buy 5 kilos of apple to be home delivered, it should not change the value from 5 kilos to 1 kilo, but still charge me for 5 kilos. Okay, that is changing the integrity of my data. Though I said 5 kilos and paid for 5 kilos, it only shows 1 kilo to the vegetable vendor, okay, or the website owner, right? So that's why integrity is very important. So whatever data person A sent, it should remain the same way until it reaches the destination. So at a very high level, that's what integrity means. But if you guys are more interested, you should Google the CIA triad, or confidentiality, integrity, and availability. Okay.
Sandesh, do you also want to use this opportunity to explain the term software integrity?
Sure. Yeah, absolutely. So when we talk about software integrity, right? So again, this was in the CIA triad I spoke about is in the context of regular security. But in terms of software integrity, what we mean is that the software that you write, the code that you write, right? It should be it should have, the integrity of the software should not be modified, right? So there are 2 or 3 different aspects here. So one is that when you download a software off the internet, okay, you want to make sure that the software you're downloading is, that you downloaded is actually the software that was intended to be downloaded by the owner, right? So if you go to some websites, they'll have something called like an MD5 hash that you can see, that you can take, and then you can verify if the software downloaded is exactly the same or if somebody had changed it in the middle, right? So that's one aspect of software integrity. The other aspect, which is what we work on in Synopsys, is basically to make sure that the software that you write, right, behaves in a manner that you expect it to behave. Okay, so when you write large amounts of software, very complex software, right? So when you write software for spaceships or for nuclear reactors, etc., etc., a small malfunction, a small change in behavior can have catastrophic effects. So it's very important that the integrity of the software is maintained. Okay, so there are many aspects to it, but two important aspects to it is quality and security. Okay, so if some software is supposed to run in 2 minutes, okay, and if it takes longer than 2 minutes, then the next action may get delayed, which may lead to some real consequences. Then the software should be written in such a manner that no matter what, it finishes in 2 minutes. Okay, that it runs in 2 minutes, or some particular action happens there. So that's important from a quality perspective. So there's performance, there's integration, different kinds of quality that you have to worry about, memory management, so on and so forth. And from a software security perspective, of course, we spoke about a lot of different things. There are many different kinds of security controls that you have to implement properly in your code. Everything from cryptography to randomness to validating data that you're getting from others, and so on and so forth. So from a software integrity perspective, what we really mean is quality, what we mean is security, and also that the software behaves the way it's expected to behave. Karthik, do you want to add something else to that?
No, that's good, Sandesh. I was just wondering if that's what the person who asked the question, if that's what they had in mind. So I thought it would
Okay.
be good to explain that as well.
Got it. Okay. Okay. Last question that we have here is if you're signing into an application using different device at the same time, how can we say our login is safe? I'm not sure what this question means. Let me read it again, and wait, let me know if you kind of get it. If you're signing into an application using different device at the same time, how can we say our login is safe? So you mean like if you're logging into like an application from your mobile phone as well as from your laptop? I mean, in general, if the software, if the application is written well, that should not be a concern. Again, it depends on what kind of software. Like some softwares will not allow you to log in from two different devices, right? It will log you out of the first device if you log on to the second device. But certain other applications like Gmail or Facebook or Twitter or Instagram will allow you to do it. Okay, because they know that the use case is that there are multiple. You may log in from multiple places. So there is no single answer to it. But the one thing I can say is many popular websites like Gmail or others, right? They give you an option. If you go into the settings, there's an option to see, or even WhatsApp for that matter. It gives you an option to see what all devices you're logged in through. Okay. So for example, if I go into my WhatsApp now, and if I see where all I'm logged in from, it will say, hey, you're logged in from your Android phone. You're also logged in from your browser on your MacBook Pro using a Firefox browser, etc., etc. So routinely, it's a good idea to go look at that list and see if there's some device that you don't recognize. Right. For example, all my laptops are MacBooks, so I don't have any Windows laptops. So if somebody signed into my account using a Windows laptop, that's a problem. Or if they signed into an IP address from some other country, then that means something's wrong. Right. So at that point, I can take corrective action quickly. Okay, so that's one thing you can do, but that's only available in some websites and not all websites. So that's something to think about. Okay, I think I've answered all the questions. Abbas or Karthik, are there any other questions?
I think there are a few more questions in the Q&A window.
Okay.
Are you able to see those, Sandesh? If not, I can read
Yeah.
it out.
No, I think I'm able to see.
There are two more
So
questions actually, like some 5, 6. Do you want to do that because should we start assessment?
yeah. So how much time do we have, Karthik? Because I know we're pretty close to the end.
Yeah, so considering we have another 5 minutes, maybe we can quickly browse through the Q&A window and see if there are any more questions which we have not answered as yet.
Okay. Okay. Let me see. Uh, So this is an interesting question. It says, if email IDs are known to hackers, then can they get information? So yes and no. I mean, depends on it's not always very easy to get information just from email address. You obviously need the password as well or some other information. But there are many different ways to actually use the email address to get other kinds of information, right? So, for example, you can launch some kind of a phishing attack using that, or you can also do something called brute forcing to try and guess the password. There are also attacks like account takeover in e-commerce website, which you can do to kind of, once you know the email address and so on and so forth. So, but in general, the answer to your question is the email address by itself is not very sensitive, although it can be sensitive in some cases. But of course, attackers can use that as a starting point to find some other kinds of information as well. Okay. So next question. I think there's a question for you, Karthik. Whether it'll be a theory exam or a multiple choice question. Do you want to take that while I look for other questions?
Yeah, sure. So we will share the link to the assessment, in a little while. So it's basically a multiple choice assessment. There'll be 12 questions. So if you get 8 or above correct, then it will be considered as the passing, and we will provide a certificate to those who have cleared the assessment. So 12 questions, multiple choice. The passing marks is 8 or above.
Okay, thank you. So here's another interesting question. Can we use machine learning for authentication? So that's a very good question, right? In general, when somebody for authentication today, most of the applications we use doesn't really use machine learning, as some of you said, and as Ved demonstrated, it kind of checks the username and password, and if it's fine, it'll let you in, right? But there's a whole new area of research and some applications as well, which use behavioral analysis to log you in, to authenticate you. Okay, so for example, the theory behind this is that like your fingerprint is unique, that the way you type your keyboard or the way you press the keystrokes on the keyboard is also unique. Okay, so they may be able to identify you the way you type as well, right? So these are all cutting edge research areas. There are not too many real world applications today, but behavioral analytics can be used in authentication at some level, and to make behavioral analytics work on an application, machine learning is used often, right? So in theory, the answer to your question is yes, but in reality, there's a lot more research to be done, a lot more applications need to be formed, etc. So today authentication is not never machine learning is not used for authentication, but it's used to detect fraud a lot. So it's the more useful is it will not replace password, but it can try to guess if somebody who entered a password, they'll say, okay, you entered a password, but this person logs in usually from Bangalore or Mysore, but suddenly they're logging in from Jaipur. So what's happening, right? So machine learning can think that way and come up with possibilities of whether there's any fraud going on here, right? So that's the research at this point, but we never know what will happen in the future. Maybe we can use machine learning for some kind of authentication. Okay. All right. Okay. So, sir, in Facebook and Instagram has login structure of username and password. If you can log in the user without original password, well, let's be very clear, right? Facebook and Instagram are reasonably secure applications. So you can log in. I mean, SQL injection only works if the application is vulnerable to SQL injection. Okay. It does not work on all applications. So unless an application is vulnerable, it is not going to work. The method that Ved showed you. Okay, so the answer is no. It will not work on applications such as Facebook or Instagram. Okay, but there's something called bug bounties, which can be a separate talk if Karthik wants, and there are ways of kind of exploring that. But that's a topic for a different day. Okay, we have 1 minute, so let me just see if I can take one other question. Okay, in MVC, in Model View Controller frameworks, application security belongs to only client, middle tier, or server side also included. Good question. As always, security needs to be implemented at all layers, right? I spoke about defense in depth in response to another question. It's the same as well. A lot of security controls need to happen everywhere, but the most important needs to happen in the server side. Okay, so in the controller, in the case of an MVC architecture. Okay, so you can't rely on the client side security controls to give you all the protection. Okay, so at some point Ved spoke about input validation. If you do input validation only in the client side or only in the model, in this case, that is not sufficient, because that can be very easily modified by an attacker, because they have control over what data goes from client to server. Okay, so it's very important that any kinds of security controls are implemented in the server side. Sometimes it's useful to do it in client side and server side, but you can't just do it in the client side. It's very rarely is it helpful, except in certain kinds of vulnerabilities. Okay, I know there are a lot more questions, but we're running out of time. So thank you very much for all the questions. We really had a good time. Ved, anything you want to add?
No, Sandesh, I have nothing else to add.
Okay, Karthik, over to you.
Yeah, great. It was a very good session. Thanks a lot, Sandesh and Ved. Your expertise and passion for software security was very obvious. So thanks a lot for taking this webinar. I'm sure this was very helpful to all the participants. So we will be sharing the link to the assessment right now. The link to the assessment will be provided in the chat window, the Q&A pane. The link will be open for another 60 minutes. So it's a 12 questions, multiple choice. And you have to get 8 or above to pass the assessment. We'll also share the link for the feedback form. Request you to provide the feedback to us. If you think there are any other topics we should cover in this series of webinars, please do let us know. Your feedback is very valuable to us. With that, we'll wrap up now. Thanks a lot to everyone who have joined. Please stay safe. Follow all the guidance by the government in this COVID scenario. And yeah, look forward to seeing you again in our next webinar. Thanks. Bye for now.